Hi, so today we are going to continue with chapter 4, which is matrices and system of linear equation. There are 3 lectures for this chapter, this is the first lecture out of 3. Okay, before we continue with the main course, we have to know what are the subtopic in this chapter. So there are 4 subtopic for this chapter, which is the first one is 4.1 types of matrices. This subtopic is really important because we are understanding the matrices itself, which is the basic concept of matrices. The second one is to find the determinant of matrices. It's not just determinant, but there are several values that you need to know about matrices. And the third one is the inverse of matrices, which you will use all your knowledge from 4.1 and 4.2 to get this inverse matrices. And the last one is the system of linear equation with 3 variables. So we mostly will deal with 3 by 3 matrices for our levels. Okay. Subtopic 4.1. So for this lecture, we are going to focus on 4.1, which at the end of the lesson, students should be able to identify different types of matrices. And then we have to perform operation on matrices, which include addition, subtraction, scalar multiplication, and multiplication of 2 matrices. And the last one is to find the transpose of a matrix. So for the first part of this lecture, we are going to focus on A and B, first and second, and the third part. Okay, so let's see some situations. So this is the result for Euro 2006 of Group B. So we have these 4 countries from the group, which is France, England, Croatia, and Switzerland. So we have this type of position. What is P? W, D, L, G. And we have the total points here. Okay, so how can we represent these results of Euro 2006 for Group B? So what we can do is, these data are presented in rows and columns in rectangular array known as matrix. So we can write down this as a matrix. So this is some example, but we are not dealing with the higher matrices size more than 3 by 3. So what is a matrix? A matrix, a rectangular arrangement of numbers in rows and columns. So we will have rows and columns. For example, 4, 7, 3, 2, 5, 9. Where is the column? The column is to the bottom. So from top to the bottom, we count it as 1 column. So this, how many columns for this example? Yes, we have 3. This is column number 1, column number 2, column number 3. Okay, and then what is row? Row is the, yes, is the horizontal one. So we're going to have 2 rows for this part. This is row 1, this is row 2. Row 1, row 2. The order of a matrix is number of the rows and columns. So we are multiplying rows with the columns. So for this example, how many rows? Yes, we have 2 rows. 1, 2. And then how many columns? Yes, we have 3 columns. Column 1, column 2, column 3. And the entries are the numbers in the matrix denoted by Aij, where I and j is depending on the number position of the row and the column. For example, for this example matrix, we have A1, 3, which means the position A of number row is equal to 1 and number column is equal to 3. So row 1, column 3. So the element is 3. There are several types of matrices. The first one is row matrix. So row matrix is a 1 by n. What is 1 by n? Means that the number of row is equal to 1. Okay, so matrix which has only one row, so one row, so only have R1. Okay, it doesn't matter how many column we have. If it has one row, it is a row matrix. And then for example, matrix A is a matrix with 1 2 3 4 5 on the column but only have one row. And B also a row matrix. The second type of the matrix is column matrix. So it will be the opposite of the row matrix. So we only have one column. So it should be on the vertical. Yes. So this is the example. Example 2, A is 0, -4. So it's going to the bottom. And then example B, 2, 3, 5, 7 going to the bottom. Okay. The third type is square matrix, means that we have the same number of rows and the same number of columns. So it can be n by n, m by m. It doesn't matter whether how to represent it, but it must have the same number of row and column. For example, A is 1, 3, 1, 8. So how many rows? 2 rows and 2 columns. So this is 2 by 2 square matrix. And then for this example, we have 3 rows and 3 columns, means that it is a 3 by 3 square matrix. The fourth type of the matrix is zero matrix. Means that any matrix with the element of 0. So all the elements in the matrix is equal to 0. So we denote it as 0. For example, zero matrix is 0, 0, 0, 0. It can be 3 by 3. It can be 2 by 3 by 2. It can be any size. Okay, before we continue with the next type of matrix, let me explain about the leading diagonal. So let's say we have a matrix A with these all element, and then what is the leading diagonal of this matrix? The leading diagonal is the elements with the same number of row and columns. For example, for this one, so we have A11, same number row and column. The element on the same number row and column, A22, A33, and so on, and AMM. So this middle diagonally is a diagonal leading diagonals. Okay, so the fifth type of this matrix is a diagonal matrix. So what it means by diagonal matrix? It is square matrix. Square means that the size must be the same, which non-leading diagonal entries are all 0. So what it means? So we can have value on the diagonal part but not in other parts. All other parts should be 0. For example, so A is a 2003. So for the diagonal, leading diagonal, we have some value, but other than that, it will be 0. Example B, so we have 100, 02, 0003. So we have value 1, 2, 3 on the leading diagonal, but not in the other entries. And example C, the same as the others, we have value on the leading diagonal. Okay, even though this is 0, still we have values on other places of the leading diagonal. Okay, next one is identity matrices. What is identity matrix? It is a diagonal matrix. So we know what is diagonal matrix. We have value on the leading diagonal where all its diagonal entries are 1 and denoted by I. Okay, so we have value on the leading diagonal, but the value should be equal to 1. So this is for 2 by 2 and 2 by 2 identity, and then this one is 3 by 3 identities. Okay, so the next one is lower triangular matrix, and then notice the part lower triangular. So the lower part of the triangle is a square matrix whose elements above the leading diagonal are zeros. Means that we only have value on the lower triangular part. Okay, let's see for the example. So this is the example. Notice that we only have the value on the lower triangular parts. So other than that means that the top one will be equal to 0 for every element. Another example is A, B, C, F, D, E. The top one here is 0. So we have the lower triangle part with values. So the opposite of lower triangular matrix, it should be the upper triangular matrix, means that the elements below the leading diagonal are 0. This example. So we have 1, 2, 3, 0, 2, 4, 0, 0, 3. So we have only the upper part of triangle. And then this example R also have the upper part of the triangles. Okay. Now we continue with the next part of the learning outcome, which is operation on matrices. So the first part is addition and subtraction of matrices. Is really simple. What you need to do is to add up or subtract depending on the element. But it means that the matrix should have the same number of element. If A is a 2 by 2, so B also must be a 2 by 2. So if the size is not the same, then they cannot be adding or subtracting from each other. Okay? The addition or subtraction of two matrices with different order is not defined. We call it as not defined. If that is question on the exam, we should state that because the size is not the same, then the addition or subtraction is not defined. Okay, we call it as incompatible. So let's do some example. So simplify the given quantity for A and B. So is this A and B have the same size of matrix? Same order? Yes, this is 2 by 2. For B also is 2 by 2. So we can do the operation. So for A plus B, so what we should get, we adding up all the elements in all the element depending on the position. So for example, for A11, here is B11. So adding up A11 with B11 will be 1 plus 4. And then 2 with 3. And then 3 with negative 5. And then 4 with 6. So what is the answer? We will get 5, 5, negative 2, 10. And then for question B, we need to subtract from each element. So it will be 1 minus 4, 2 minus 3, 3 minus negative 5, 4 minus 6. So we will get the answer for every element, which is it's still a 2 by 2 matrix. Okay, the next part of the operation is scalar multiplication. What it means by scalar is a constant. So we are multiplying a constant to the matrix. So C is a scalar and A is a matrix. Then C multiplied by A is a new matrix where the element will be multiplied with C. Every element in A will be multiplied with C. So let's do some example. We have matrix A and B, and then calculate 3A minus 2B. So we have a scalar of 3 in front of A, and then scalar of 2 in front of B, and then we have the operation 3A minus 2B. So let's do this. So 3A minus 2B, we just have to write down what is the matrix A and B. So 3 multiply with matrix A, 1, 4, 5, 3, minus with 2 multiply with 3, 6, 4, 2. So what we should do, we have to multiply this scalar with all the elements in the matrix. So 3 multiplied by 1, 3 multiplied by 4, 3 multiplied by 5, 3 multiplied by 3. So what we should get for the first part is 3, 12, 15, 9. It will be the same as 2b. So 2 multiplied by 3, 2 multiplied by 6, 2 multiplied by 4, and 2 multiplied by 2. So we get 6, 12, 8, 4. So what we should do? Now we have to do the operation of subtraction. Okay, so subtract each element depending on the position. So 3 minus 6, negative 3. 12 minus 12 is 0. 15 minus 8 is 7. And 9 minus 4 is 5. Now we get the answer. So these are some properties of the addition and scalar multiplication. So for addition between two matrices, it is commutative because A plus B is equal to B plus A. It doesn't matter about the position. And then A plus B in a bracket plus C, and then is equivalent to A plus B plus C. So B plus C in a bracket. Why? Because it's only addition or subtraction. We can solve any part first. And then the third one, A plus a negative of A is equal to negative of A plus A, which is equal to 0 matrix. So it's a negative of matrix A. And then a scalar multiplication multiplied by A can be expanded into A alpha A plus beta A. So we can expand as usual, where A and beta, alpha and beta is a constant. And E, probability E, when we have a scalar multiply with a matrix of A plus B, we can also apply the basic expansion, so which is equal to alpha A plus alpha B. And the last one, if we have a constant alpha multiplied with the bracket of beta A, where alpha and beta is a constant, it can be written as alpha beta, the two constants multiply with each other, and then we multiply with matrix A. So this is the first part. We continue with the next part.